Let's look at effectiveness. Effectiveness is there. For 20 centimeters we capture, we have 50,000 counts per second. We could increase it by 1,000 times. We know that cannot look for the ideal thing. We need to reach a compromise between performance and price. So making an analysis, I see that with 400 time increase I can reach an effectiveness which allows me to have early detection, early screening, that is low radiation dose. You find this information in the paper I've given you, and that is the question we need to raise to all people working in this field. Do you have any scientific arguments which can invalidate the benefits or can question the results of 3D CBS innovative technology, or can you point out any other more meritorious solutions? From the parameters we have seen that are common to all crystals, what are the main problems we need to solve? Filtering noise, because we want to capture a specific photon, 511 keV, not another photon. Then we want to measure in a precise way the arrival time of photon. We want to measure its energy. Is it 511 keV, lower if there was a scattering, and X, Y, Z coordinates where the photons hit the crystal, and we want to capture as many photons as possible because we want to reduce radiation dose and have an early diagnosis. These parameters are linked to the possibility of saving lives. So what is the problem I had to solve? The problem was data I have at my disposal are the ones supplied by a transducer, that is the crystal, that can be made out of smaller crystals or only by one crystal. Once the photon hits it, only one photon, 511 keV, and these photons generate a beam of photons that is light of 420 nanometers of length, which goes every direction. So I have a transducer which converts this light of photons from one single photon, that is called photomultiplier, in a matrix that is here. Then in the front I have an APB that is very thin, 300 microns, which does not stop photons. And then I also put a light guide which detects the signal of the beam of photons and captures it. So I have XY matrix of signals, and I give you an example of these signals. It can be this signal. You see this sort of jump. You have two close photons. It is called technically pile up, or you can have a low signal. You could have here a high signal where it hit the crystal, and then closed photomultipliers you have a low signals. So you need to get the arrival time. What is energy? Energy is the area added to the other areas. XYZ is the interpolation between all these X signals and Y signals, and Z is the interpolation between the photomultiplier and the APB, which gives me the Z distance. So I found a solution of how to perform precise measurements, but we need time to carry out this measurement. What did we do in 17 years ago when I was working at CERN? We were working with fast electronics, ACL, other transistors, gallium arsenide, but this was very expensive, and this did not allow us to make all these calculations to work with interpolation for X, for Y, for Z. So we were at a bottleneck, and I had to solve this problem with an invention that is the one. If you go on the website, you will see the explanation of this notion. You know that if the notion is simple, also some boys and girls can understand it. I visited a school called Sant'Antonio School, and we made an exercise in the school with some boys and girls using a corridor and a classroom with a group of students which was working as a microprocessor, and the corridor was the flow of data from the detector. So there was a datum arriving every 6 seconds, but students in the room said that they needed 30 seconds to analyze that datum. So I put a boy at the door, so taking the first datum, the first result, putting in the corridor. The second classroom, the boy does the same, take a datum and puts in the corridor. So the first boy takes the datum and put it there. The second datum is bypassed, the third is bypassed, the fourth is bypassed. Why? Because students from that classroom needs 30 seconds to analyze one datum. But these data are not lost, they are analyzed by the following classrooms. That is the notion explaining the technology. So the processor or the classroom are these ones. The boy at the door is the bypass switch, that is that arrow, which takes one, gives it to the classroom and bypasses 4 data, and this is what all boys at the door do. This was a class register which was put in a box and which was put in the box and taken from the other boy. If you look at the animation, then you see that the datum at a certain point generates a result which is R1. R1 goes into the chain, but it is not analyzed by other classrooms, as it happens in a production line that you all know, production line for water bottling, for car manufacturers, for motorcycles and so on. But this datum, you see there the bypass switch, and you see the flow of data with the table, and the datum which arrives stops there for 5 clocks there, then moves on. This was the representation, technical representation of what I've shown you. It is an array of processors that I have implemented, tested, that is working. You find there the card. Rather than having a darkened light, you have numbers which give a value. This is 3D CBS, which is a CAT component measuring the density, and another component so basically, once you have a barrier, an obstacle, you need to find a real solution, and the solution in this case allows us to perform all algorithms measuring XYZ energy and the arrival time of a photon, and can filter it and eliminating and separating it from noise. So that is the core of the technical argument, and I would like to have a comparison on this core of a scientific argument. And I would like to make a comparison with a super collider from CERN and all colleagues. And I've given you a paper that will be published on the web, and you see that I've been acknowledged by the most important representatives of the 3 most important laboratories worldwide, which were at that time even if super collider does not exist anymore. It were CERN super collider and Fermi National Laboratory, which have the Tevatron accelerator, which was the most powerful. So all representatives, apart from one, agreed with me and followed my direction. I met a representative in 2008 at CERN and said that this was a real solution, and in the case of physics synergy, made the ECL gallium arsenide obsolete for this kind of applications, because we can of course reach a compromise between performance and cost and take the off-the-shelf technology to try to have the cheap solution. In this case, we used before block detector, which had problems in looking for X, Y, and Z coordinates and capture all information from the detector. At this point, since I had the possibility to analyze any kind of data with complex algorithms with long duration, but at the same time I do not lose incoming data because these data were bypassed to the following step.